Hey guys, today I'm going to be going through 5 Leetcode questions, furthering my practice with Java. So I just picked a combination of some tree problems, some counting problems, and then also subset or combination problems. And then also one of my personal favorite data structures, tries. So I keep on, the goal for me is just to keep on answering uh, easy to medium questions in Java till I get a good handle of the actual language. I'm more used to Python, and yeah, it's just a couple quick problems, and I kind of understand the underlying principles or data structures and algorithms for how to answer these problems. So, for example, this one I'm probably going to be using a queue and breadth first search, but yeah, I'm just going to do a couple till I finish them all or get tired. We'll see. But yeah, this could be my late night stream of me answering these questions in Java, so I'm going to have fun. All right, let's just do a little stopwatch. Perfect, let's start there. All right, so yeah, like I said, what I'm going to be doing first is a deepest leave sum, problem number 1302 or 1302, and then given a binary tree, return the sum of values of its deepest leaves. So, like I had mentioned, I think breadth first search is going to be the best here, and the reason I say that is because you kind of look, your deepest leaves are going to be found with breadth first search. So, you can also do depth first search if you wanted to too, but you just get that easier kind of combination of just doing it level by level. So, for example, let's say you only have 3 nodes, 1, 2, 3, then you'd have an answer of 5, and then you could just easily do a breadth first search there. With depth first search, you're like checking every possibility, and I guess you are to a certain extent with BFS too, but I think it's just easier to like really calculate that number if they're all in the same queue. Okay, so how would we determine that with a BFS? So, for example, if there were no children on that last level, then I'd use sum all the values together. So, on this example 1, you have 7 and 8, and that would yield 15. And how do we know that those are the last ones? So, you would that'd be in the queue, this last iteration, you'd have 7 and 8, right? So then you would pop 7, realize it did not have a left or right subchild, same with 8, and then you just have a running total of 15. So I think all I have to do now is determine a way in Java to easily implement a queue. I'm not as familiar how to do that in Java, so I'm going to have to do some Google searching. Yeah, Python is just the collections library, so let's see if there is an equivalent on Java. Java. Alright. Oracle documentation, we got a queue, so that's a collection. You have insert, remove, examine. So why do we use queues for breadth first search? It's just the way it's structured. It's first in, first out, and that kind of is conducive to level by level traversal in a tree. So add, offer, remove, peak. Okay, cool. So all I have to do is use java.util.q so it's an interface. So I don't think I can instantiate an interface right in Java. So I wonder how I would be able to use it. It's a collection. So maybe it's a collection that I have to. So let me put that in a new tab. And here, how do we actually use it? Thank you, Geeks for Geeks. Actually, let's go there because it's gonna ask me to sign in, and I just do not want to do that right now. Okay, let's go to baildung.com, offer, poll, peak, abstract queue. Okay, so yeah, you could do a linked list, generic, I believe. And then, yeah, you would you're doing a linked list generic. Interesting. Okay. So you do priority queue, new priority queue, and you add them. You can remove them too, I believe. Okay. So maybe you have to use a priority queue. Let's see. Oh, okay. So now we just got normal queues. Okay. How do we use a queue? I'm sorry, my laptop is going a little bit extra. I think it's all the ads. So now I just have to, avoid that. So, okay. So this queue implements iterable item. First, last. Okay. Thank you, Princeton. Okay, so let me just do BFS. That'll help. Oh yeah, no, it's Geeks for Geeks. So good website. Just do not want to sign in. Prompt that. So how do we do this in tree? Okay. Okay. So it seems that we have a queue of this class. So let's just check this problem. We have a class tree node. Okay. So if I just do check this right here. Queue array deck. Okay. Array deck. And we got to name the variable too, so q dot add, we got root. Okay, so what if the root is null? So if root is null, then we're going to return an int, which would be 0. Okay, cool. So while not q dot is empty. Okay, so what am I doing here? I'm basically just doing indefinite iteration for this queue. So the general structure is going to be we have this first element 1 in the queue, then we check if it has children. If it has children, then we add those children to the queue. Then the second level, you're going to have 2 and 3 and check if that has children, and then the next things that are going to be added to the queue are 4, 5, and then 6, and so forth and so forth. So you can see it goes level by level. Within this while loop, you have a secondary loop, which is basically you're doing a for loop to make sure that you're only going the amount of elements at that level. And how do we determine that? Well, we do that by checking the current size of the queue. So for example, like the first level is going to only be 1 node, and the second level is going to be 2 nodes. In this example, you're going to have 3 nodes on level 3. So it's going to that inner for loop is going to iterate 3 times for these nodes. So 4, 5, 6. 4 is going to have a child, so that's going to be added to the 4th level. So let's just go code that up. So size equals, and I think q is, let's see, how do we get the size of, okay, let's go back here, array deck, Java. Right deck. Okay, so you can add that, perfect. Now how do we check the actual size? Okay, perfect, so size, open parentheses. So q dot size, and then we do for int I equals 0, I less than curve size, I plus plus, oops. So this is kind of the standard way that you would just structure this in Python. Something similar, just there is a lot less types, and also, but yeah, the general structure is the same. Like you do a while loop on your version of a queue. You add the root node initially to that queue, and you just run that while loop until the queue is officially empty. Within that while loop, you iterate over the current size, and then you add new elements to the queue if it has children. Okay, and just given this, if there are no children, then I think we can add the subtotal. So let's do subtotal equals 0, which I think we could put here. So we're only going to return this if there are no children. So actually, we would probably want to so we want to return total somewhere. So total equals 0. At the end of this, we want to return total. Why integer? Because that's basically what we're going to return. Okay. So I guess we can just have some type of simple boolean that children present, or like child found, like children node found equals false. Okay. So within this, now we got subtotal, and then we, oops, and then we have current value, or current node, and make that be it. So equals q dot, and then let's see what array deck is our pop. Yep, okay, so pop. Okay. So yep, it's just pop. Then we add the subtotals, subtotal plus cur node dot val. So basically I'm asking for its child, like if left and right is null, turn it. So if it's false after this, then we can add that new subtotal. If not, okay, so for child's found, cur node dot, oops, I'm going to open up parentheses here. Cur node dot left does not equal null. Q dot add cur node dot left. if node dot right does not equal null, same thing. Q dot add node dot right. Then yeah, we just change this children node found equals true. Same thing here. So why is it true? Because you have a child, so that means that they're you're not at the last level. Okay, so from here you have your final loop, which I think after you iterate. So if not children node found, then you could then total is your subtotal. I guess you return that. This makes sense here. Equals subtotal. If not, then you on the next loop, then while I think it just turns back to 0, but then you have to change this back to false. Okay. I don't even need to do this, because on your last one you're just going to update it anyways. So yeah, I don't think I need this complicated. Yeah, I might not need this, so I can just actually do subtotal. Oh, okay. Let me get rid of that subtotal here because it's out there. Don't need that because again, at your last one, you're going to get it anyways. Yeah, I don't need that. Subtotal is going to be 0 anyways. Okay, yeah, because your last level, if I'm doing this correctly, yeah, your last level is going to just rewrite total, and total is going to be 15. There might be some error where I'm actually getting 9, but 15 because I'm not considering the last loop. But I think this would possibly be right. So yeah, let's check this out one time. Oh yeah, and then also you might be asking what is the time and space complexity. So since we are using a deck or queue, we're visiting every single element. So I think that's O in space. In terms of breadth first search, I think we're doing OV plus E time. I could be wrong there. I'm a little rusty on tree traversal time space complexity. Okay. So we got a tree node here. We add the root, which is our input right here. If null returns 0, int equals 0, while q is not empty. Cur size equals q dot size. Subtotal equals 0 for this. Pop the current node. Okay, that's wrong. It's tree node here. So we're adding to the subtotal. So if we're at the last stage, then we're not adding anything to queue, but if it has children, if children present, children node present, then add to queue, That's what we're doing with these like little conditionals, cur node dot left does not equal null, so there's actually a value there. Then you just add that to the queue. Same thing with right. And then at the end of this little for loop right here, you just rewrite total to the subtotal, and at the last level it's going to be 15, and that will return 15 at the end. So let us run that. Oh, and I forgot to add a little semicolon. I think this should run, especially since we changed the tree node type here. Yeah, and we are returning integer, so let's do that. Did I type this wrong? Q.pop. Okay, so we're adding root. Let me just do that. Oh, so it has initial capacity to handle only 16 elements. Okay, I might have to change that then. So what are we returning? Okay. So add E, remove, add the Q. Oh, so it might be remove. Oh, okay, I see it. Okay, so I used the wrong method there, so remove. Let's do that. All right, so this seems to be right. So thankfully, yeah, this just rewrites. I think the only bad thing is like you are rewriting, so you are capturing, at least in this instance, like 3 levels of subtotals you don't need to. Yeah, so there's probably a way to avoid that. But let's see if we pass a majority of our test cases here. Oh, nice. Okay, so that's been solved. Can't see the solution, but yeah, I think there's just a way like you can avoid the certain levels of subtotals. So you technically are only saving like the levels minus one operations, but let's say you just have a super big tree, that could actually be a pretty big speed improvement. But yeah, okay, so we completed that one. Let's go to the next one, permutations. Before I do that, I'm going to take a little tad break, and we'll be back in like 2 seconds. Yeah, so I think the cool thing about that problem is I probably would have been able to solve it similarly in a similar fashion with Python. It's just I'm not too used to using certain uh, not objects, I guess like certain types, collection types in Java. So I got to learn a lot there. But yeah, it was really cool to use the array deck and yeah, learn more about that. Okay, so let's do permutations. So how I've done this in Python and I'm probably going to be doing here is some form of recursion. So just being able to call itself. Let's see. And you got to return that output there. So that's cool. Yeah, I kind of know the pattern for this. It might be a little difficult to implement here, but let's do it. Okay, so kind of same thing. Okay, so I'm just doing a little helper, makes it easier for makes it easier for makes it easier for um, this. Just keeps it a little bit abstracted, and I think for the recursion it helps too. So should I have an output here? So yeah, let's do that. So I can just do this. Equals new array list, then array list of list integers. And I might be wrong with the typing here, so I'll probably have to look that up. So this will be output. So we're returning the output eventually here. Actually, if I don't really need to do that, I just return output because that's going to change it, I believe. So we just do void here. So, oh, we gotta do, oh my god, yeah. We have to do IDX too. Okay. So, integer here. If IDX equals len, oh no, what's that? Len. Okay. Index, so I know how to do it in Python. You could just do like a little colon in between the indexing and get everything. But let's do indexing in Java. So it looks like you can only do one character at a time. I wonder if you could do multiple. Okay. Let's do every element. Okay, this might be a little bit more than I can chew here. Okay, I think I really just do append that. Okay, let's try that out. Output dot add else, and for int j equals 0. And I'm kind of just doing this similar to Java. these are integers. Okay, so int equals temp equals nums I, then nums I plus plus, nums I equals nums j, which equals nums j equals temp. Okay, yeah, that works. J is less than nums dot length, j plus plus, and we have swap permutation helper. So basically what's happening here is that you're swapping every single permutation, going through this loop, and then you're just adding dx plus 1. So then you just have this. So you're swapping elements, then unswapping them. Oh, okay, gotcha. idx and then j. Oops. And same thing, you just reswap them after the recursive call. And then like once you get to the last one, oh, okay, -1, then you just add that version of nums. Okay, output.add. Okay. All right, let's check this out. This is kind of like my Python code. Oh, God, those little tiny errors. Oh, no, it's less, okay. How to instantiate this. Turn new array. Oh, array list integer. It's a new array list. Okay. Oops, wrong one. What's this say? It needs to be concrete type like array list. Ow. So, new array list. Let's see if that works. Boom. Okay, does not work. Okay. Alright, how do we do this correctly? this works. Copy and paste. And now let's change that back to output. Okay, output.add nums. Okay, how do we add to that though? This dot add in the list. Okay, maybe I can do some casting here. So double casting. Okay, definitely not. Okay. Okay, so yeah, we have our ints here. It's not letting us add there. Okay. Maybe that's it. I'll raise the list. Okay, did I write that correctly? Oh, this typing. Yeah, that's not something I'm used to with like Java, like getting used to all these like different typing or like outputs. Something you gotta look into, get better at Java. Blah. Okay. Ooh. Okay, how do I convert this integer, this array of integers to a list? Oh Okay. Do this the dumb way. Oh my god, this makes no sense. Why is it so complicated to create this output? Okay, I'll just go ahead and do it. Stop complaining. New array list integer. List integer. And this is nums.length. Oops. Nums.length. And then I gotta name this. So I'm gonna do sub permutation perm for int nums perm dot add num. Boom. Let's see, that's right. Looks right to me. All right, let's try that out. Okay, so the permutations are working. Now I just gotta make sure that there are no duplicates. And just return here if that's not the case. Let's try that out. Boom. Okay, so I think this is a lot more complicated than it needs to be, but we'll see. Okay, cool. So it's similar. I just gotta work on the typing. The typing seems a little silly to me, but I mean, it's just something I gotta learn. Okay. I'm gonna have to review this later, but yeah, so if I have these like interfaces like list integer, I have to create that output, and then here, since I have an array and not a dynamic array list, then I have to create that sub portion right here, so like list integer, which I'm doing here. So I call it perm array list integer nums.length, and then I have to iterate and add the current ordering of nums, which, you know, the permutations get swapped here, and I had if that current permutation is not in output, then add, if, then just return. Interesting. Okay. Subsets. Let's see if I can do this one. And we had the same list. Okay. So for this, from what I remember, you want to start with an empty array. Yeah, you want to start with an empty array. Okay, so from what I remember, right there, for the last problem, output equals new array list integer. Okay. And then we want to do start. So we want to do like a start, yeah. Or like empty array bar equals new array list integer. Oops. And let's do that. Have that be 1. So only one size of 1 here, and that's basically gonna be output add empty array. So yeah, basically what I'm trying to do is, for the start, it looks like this. So I have the empty array in that final output, and then like for each number, you're basically just multiplying within that array, which I think will be difficult because I don't know if there's an easy way to do that in Java, but we'll see. Alright. And kind of similar to like BFS and like using queues, just to make sure we don't get stuck in an infinite loop. I think we're going to have to do something like cur size with output. So it's like a limit there when we add new numbers. Okay. Okay, so for int element elam nums, so for that, and then you want to do the size, so for int I equals 0, I less than output dot length I plus plus. Okay, so for that elam, and then for the size, and you want to do, is there a way to like multiply that? Concat? Okay, let's do this. ArrayList.concat, ArrayList.concat, Java. Just to add that's the second list to the first. Okay. Okay, that makes sense. So what we do here is we do output output I dot add all. Oh no, dot add. Output I dot add all. And then you want something in here, which would be like elam. So in that case, yeah, you want to like initialize. So with this, to array list, arrays as list, okay. Good to know here. So with this, list integer sublist equals new array list integer. new array list. Oh, okay. New array list. Arrays dot as list, and then here's gonna be where elim is. Okay, and here you add sublist, and then that stops like after you reach the current size. Okay. So in that case, we don't need I. Okay. Alright. Look, that might be reasonable. At the end, you just return output. Then, of course, if nums is null, then you want to return empty. Okay, let's try that out. Okay, did I miss something? Okay, let's try this out here. Array list integer. Integer. Now that appears right, but let's make sure. List integer. See if we get the same error. Okay, list integer. Oh, shoot. Been silly there. Cool. Okay, same thing here. So I don't need those extra parentheses. So maybe in array lists like that. Maybe it's size. Yeah, I think it's size. Okay, so now we gotta do dot get. Okay, list index Java. Okay, that's fine. Here's the boolean then. Okay. Okay. It's the booleans. So is there like a dot put I could use? Okay, what am I doing wrong here? Okay, so this is definitely not like Python. Okay, so maybe boom. List. Okay, maybe that's what we have to do. Sublist. Okay, so let's just get rid of this and see what it yields. Okay, time exceeded. Get the node there. Okay, time exceeded. Size of output. Oh yeah, okay, that's what I have to do. Okay, so and curve size equals output size. Just go there. Curve size. Just do that. Sublists. Let's see what that yields. Okay, so you can see that we include everything there. And now we want to oh, subset. Okay, let me add subset. Add array list to another array list. Then Java. Okay, so yeah, basically I think I got the underlying structure right. I just got to figure out how to add two sublists together. I hear I was getting wrong. Okay. Jeez. Oh, man. Wish I knew how to do this. Okay. Okay. So was it saying that? So we get a boolean right there. Boolean changed equals that. Oh my god. Add all. Output. Okay. So it's kind of doing what I want, but definitely not. Okay. Not what I want to do. Oh, that's it. Okay, output.get. Boom. Let's see if that works. Okay, kind of. Okay, I got it. Output.get I.add. Maybe that will do it. Interesting. Interesting. But where the fuck is true coming from? So list eat no. Okay, so the subset. So true, 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 true. So maybe dot get I dot add boom. Maybe that's what the truth is. So the true is an empty array. Alright. Yeah, so there might be have to empty array list. Yeah, it's probably gonna be something I have to do there. Yeah, this typing stuff with Java is interesting. I gotta get a lot better at this. So I think I got a variation of what I was trying to do, but like when obviously it gets to true, it's like an empty array. So maybe it defaults to that. So maybe I just need to do this. I wonder if that changes anything. Okay. Not at all. Okay. This will be a to be determined Java. Let's see if I'm game for these. Frequent. I can sort this. And then just do a count. There's that ordered dictionary, right? So there's an ordered hashmap. Ordered hashmap. Java. So for this, so ordered by key. Okay, so there's no counter. So tree map. Okay. Ordered hash map counter. So yeah, what I'm trying to do here in this next question is I essentially create a counter dictionary, and then you just do the K most frequent items. So how do I do this in Java? All right, so in Java. All right, let's check that later. All right, yeah, I'll check that later. But yeah, that's what I do is I just create a dictionary, and from a dictionary you just search the top elements there. So you sort that. So how do you sort a hash map? Sort. By value. Okay. That still keeps the. I'll have to look at that later. Cool thing I got those two figured out, and I'm gonna try. Yeah, what's up? See you guys next video.